All right, I just want to run through a few more examples of limits graphically, just so we can make sure that we're good moving forward. Got a lot of examples over here, but if you notice, some of them are to the left, to the right, and then of that same C value. So to the left of C, to the right of C, and then the C value, just to kind of make sure that we're good on all that kind of stuff. So let's use this graph right here. I've got the limit as x approaches -1 from the left. So I'm going to look at my -1 value right here. From the left side, it looks like it's going down to 0. 0. The limit as x approaches -1 from the right, -1. So from the right, it would be going to 0 as well. So the limit as x approaches just -1, since the one from the left and from the right are going to be the same, we got 0 right there. Let's look over, I guess we can do this one. -2 from the left. So we got -2 over here. From the left side, it's getting really, really close to 1. From the right side, looks like it's getting really, really close to 1. So from the left is 1, from the right is 1. That means that the limit as x approaches -2 is equal to 1. Okay. The limit as x approaches 1 from the left. All right, approaches 1 from the left. So I'm looking at 1 right here. We're coming from the left. The number that I'm approaching as I'm coming from the left is 2. The number that I'm approaching 1 from the right, coming from this way, is 1. And so when I look at this, coming from the left, coming from the right, I'm not coming to the same number. Therefore, the limit as x approaches 1 does not exist. Let's look at 3. So as x approaches 3 from the left, looks like it's getting close to 5 up there. As we're coming from the right, looks like we're getting close to 5 up there. So from the left is 5, from the right is 5. That means that my limit would be 5. And then at the bottom of each of these, I put f of -1, f of -2, 1, and 3, just so that you kind of can plug it in. So if I plug in -1, I get 0. If I plug in -2, I get 3. Okay. If I plug in 1, I would get 1. And if I plug in 3, doesn't look like I get anything. It looks like I get undefined. Next. All right, we got this graph. We don't have the marks on this one, so we gotta do our best here. All right, we got -1 from the left and the right. We got 6 left and right, -5, and 4 from the left and right. All right, so the limit as x approaches -1, so we're looking at this -1 right here. From the left, it looks like it's getting really, really close to -2. And as we're going to -1 from the right side, looks like we're getting really, really close to 2. Since the limit from the left and the limit from the right are not equal, that means that this limit at -1 does not exist. Okay, let's look at the limit at 6. So let's look at 6 right here. So from the left side, looks like we're getting really, really close, maybe -5. 6 from the right side, so we're at 6 right here on the x. Coming from the right side, looks like we're getting really, really close to maybe -3. From the left, from the right, those are not the same. Limit does not exist. Okay. All right, let's do -5 from the left and the right. So from -5 right here. From the left, looks like it's getting really, really close to 0. From the right, looks like it's getting really, really close to 0. Okay, 0, 0. Since those are the same, that means that the limit would be 0. Next, I've got 4. Okay, So 4's right here. As we're coming from the left, we're getting really, really close to -4. From the right, looks like we're getting really, really close to -4. So from the left, -4. From the right, -4. That means that my limit as x approaches 4 is -4. Let's plug some of that stuff in. So plugging in -1. If I were to plug in -1 to my function, I would get 2. If I were to plug in -5 into my function, plug -5, whoa, undefined. F of 6, if I were to plug 6 into my function, I would get -3. And if I were to plug 4 into my function, plug 4, whoa, got another little undefined there. Next. All right, got another kind of crazy, looks like we got maybe an asymptote right here at what, x equals 3, another one at x equals 7 right there. All right, luckily we got a 3 and a 7 right there, great. All right, as we approach -4 from the left, so we got -4, as we're approaching it from the left side, we're getting really, really close to a number, and that number looks like it's 3. Looking at -4 from the right side, looks like we're getting really, really close to 3 as well. Man, I got the dropsies. Okay, so limit from the left and the right's the same. Therefore, limit at x as x approaches -4 is 3. Notice that would not be f of -4 though, because if I plug -4 into my function, the dot is at 2. Okay, that's important. 3. So as we're approaching 3 from the left, looks like we're going -infinity. 3 from the right, looks like it's going to be +infinity. Those are not finite numbers. Those are not the same. The limit at 3 does not exist. Okay? -6. If I'm looking over here at -6, -6 looks like it's going to be 0. So from the left side, getting close to 0. From the right side, getting close to 0. Left, 0. Right, 0. Therefore, the limit as x approaches -6 is 0. Same thing down here. F of -6. If I were to plug in -6, I'd get 0. We didn't do 3. F of 3. If I plug in 3, that's an asymptote. So that's something, you know, in my denominator equals 0 or whatever. This would be undefined. Seven, right here, got another asymptote. So when I plug that in, undefined. Fancy word for that is discontinuity. We got some discontinuity there. Same thing when you have a hole in the graph, that's discontinuity. Removable discontinuity, and then non-removable discontinuity. We'll get to that at some point. 7, from the left. So the limit from the left would be, I guess, +infinity. And technically it does not exist. I'm not too worried about right now. 7 from the right, -infinity. The limit as x approaches 7 does not exist. These are not finite numbers. They're not the same thing either. Let's flip it over. Gonna sketch a graph of this function given the conditions. All right, this first one looks pretty nice and easy. F of 1 equals 4. So when I plug 1 into my function, I get 4. That means closed dot right there. The limit as x approaches 1 from the left, so from the left, we're getting closer to 1, is going to be at 2. Okay, so that means it needs to be at 2. It needs to be open dot and just something coming this direction. I don't know. It could be going down, up, whatever. It could be going down, could be kind of a quadratic, could be anything you really wanted over there, as long as it's open dot and it's going towards 2. limit as x approaches 1 from the right is -3. So -3, and you can make it whatever you wanted to make it, something like that. It could be going down the hill, doesn't really matter as long as it's approaching -3 there. Notice f of 1 equals 4, but the limit as x approaches 1 would not exist because these are different things. Next one's just a little bit more complicated. Sketching a graph. I've noticed these infinity and negative infinity here. So I'm gonna have something kind of going like, this, like an asymptote or whatever, at some point. So at 2, one of them's gonna be going up, one of them's gonna be going down. The limit as x approaches -3 from the left, so as we're getting closer to -3 right here, we're gonna get close to 1. So I guess, whatever kind of arrow you want to draw right there. And then we got -3 from the right is -4. So we're going to be down here at -4 is going to be my limit as we're approaching it from the right. So we're approaching -3 from the right. We're going to be down here at -4. And I don't want to go ahead and draw an arrow this way because something's going to happen at 2. So I'm noticing that 2 from the left, so as I'm getting closer to 2 over here, I'm going to go up to infinity. Okay, so there's going to be an asymptote right here. As I'm getting closer to 2, we're going to go up to infinity. And then as I'm getting closer to 2 from the right side, I'm going to be getting closer to negative infinity. So however you want to draw that, I don't know, something like this maybe. Let's sketch a couple more. So this is a little bit more abstract here. We got f of a, we got our point A right here, is undefined. So when I plug A in, I'm gonna get an open dot right there. And the reason it's open dot because it says x equals A is a point of discontinuity, not like an asymptote or something like that. So it's point discontinuity, and it says the limit as x approaches A exists. So, it's going to do something like that, and it's going to end up right there. And then, so that's from the left, and then from the right, it needs to do the same thing. So from the right, it needs to be getting closer to that and closer to that from the left. F of A is undefined. It's a point discontinuity. Done with that one. Next. All right, it says f of A is defined. Okay, that means that at some point there is an answer if I plug A into my graph. X equal A is a jump discontinuity. We haven't really talked about what that means, but that just kind of means that it's a piecewise function, so there's going to be like parts to it. So there was a part right there. You could jump, okay, jump discontinuity. So I need to draw another something. I don't know, at some point I'm going to have a line going somewhere like that. All right, so we got f of A is defined, and then there's jump discontinuity. There's going to be some graph over there. The limit does not exist. So as we're getting closer to A, it does not exist. That just means that from the left and from the right can't be the same. So if I make this one, if this one, I don't know, 5 and this is 3, if I have this like that, so from the left, we're getting really, really close to 3. And then from the right, we would get really, really close to 5. That means the limit at A does not exist because the left limit does not equal the right limit. Last style of problem I want to look at is this problem. It was on this sheet is the first one, and there's a lot of practice for you guys, but it's on the back of it, and it's at the bottom. So we're looking at this graph. Okay, this graph, these are the questions. So we need to decide if these are true or false and explain why, that kind of stuff. So the limit as x approaches 4 of g of x, limit as x approaches 4 equals 4. Well, let's look. We need to decide, is it the same from the left and right at x equals 4? So we got 4 right here. And as we're approaching x equals 4, looks like I'm getting 2 from the left side. X approaches 4 from the right side, looks like I'm getting 2 again. So this one's false. Let's write it as the limit as x approaches 4 of g of x equals 2, not 4. Now, where people get confused is that f of 4 equals 4, but the limit would be at 2. So f of 4 would be 4 up there. If you plugged 4 in, you would get 4, but the limit is going to be at 2. Next one. I've got the limit as x approaches 5 equals 2. As x approaches 5 equals 2. So we're, imagining this x equals 5 line right here. So as we're coming from the left, looks like it's 2. As we're coming from the right, looks like it's 2. This one's true. Number 3, limit as x approaches c of g of x. So that just means that for any value of c, any one of these x values down here, okay, the limit exists for every value between the interval -4 to 6. So that just means that a limit exists for every one of these numbers that we would plug in. Does the limit exist for this? The one that I'm noticing is 3. Like, if you're coming from the left at x approaches 3, you're getting whatever that decimal is, maybe a quarter, 0.2, something like that. If you're coming from the right, it's 2. So, no, this is false. As x approaches 3, the limit does not exist.